recommend you. I do recommend you try to download this kind of free smartphone app so you can understand more on all the those kind of typical main sensor in your smartphone, right? Remember, I just mentioned. Did you try to download that free app so that did you try to download the free download this free app about sensor kinetics, right? So that at least you in this case would be so that it be useful for you to understand more about all the sensor like in your smartphone, because this MEMS motion sensor is almost existing over 99.9% of your smartphone now. So that here just show you at this moment there's only several company dominant in this field: ST Microelectronics, right, in Europe, and also the InvenSense in Silicon Valley, United States, and Freescale, and only several companies are able to make this kind of low cost MEMS sensor for smartphone. Local means you need to do mass production, most likely in 8-inch wafer, right? And then so that you are make sure that the cost will be competitive enough. So I doing that. And anyway, so that I just told you that this is something will be interesting for all of you to understand. Your smartphone has so many sensors, right? Of course, another very common this MEMS sensor is you have this kind of micro gyro, right? As a vibration-based micro gyroscope compared with the conventional mechanical gyro. So using in maybe in World War II, right? So that definitely this is something much more compact. Traditional gyro now invented, I think most widely used in World War II is a spinning top. Spinning top is kind of gyroscope, and then with some several control system, but it's too big, right? So that I don't believe that conventional spin top can be used in miniaturize this kind of thing in your smartphone, right? So that tell you, hey, that's something. Traditional one is huge, okay? It's traditional is like you have some rotating mass, right? And then there's a motor, right? This is because of spinning mass, this kind of gyro. This is one of with some kind of control, several control, so that in this case, one have some kind of a continuous, this kind of a rotation of this kind of a mass, right? Inertial mass. So that this is a spinning mass, and then here's an omega, right? So that in this case, once you try to rotate this gyroscope, right, put on airplane, and then so that they can help to use for this kind of major angular velocity. This is a traditional, right, very big, bulky, this kind of mechanical gyroscope. Right, of course, after World War II, there's another one. It's a laser ring gyro. So it's not. Oh, sorry, I didn't put here. Another after this thing, there's a laser ring gyro. Right. So this kind of laser is quite mature. Has most 99% of commercial airline using this kind of laser gyro. Right. But still, it's too big to be used in smartphone. That's why if you can make this kind of micro mass spring system, so that this most likely is used commercial. Most likely commercial, this kind of airplane, right? Like I think this is still widely used, right? Like Boeing 77, and then so that it's a very mature. Exists this in the real market for many years, right? So that of course this kind of micro gyroscope, again, they base on micro mass spring system, so that you have apply most likely in your smartphone, apply electrostatic force to the harmonic vibration, right? Harmonic vibration, and then so once you have you move around your smartphone, then rotate your smartphone, and then cause this kind of Coriolis force, and then in this case you have this kind of Coriolis acceleration, right? this kind of thing can be used to apply effective loading on micro spring. So basically, it's still a mass spring system. I say this is still I would say mass spring mic system, micro mass spring system. Okay, M and K system, and then so this kind of correlated oscillation will cause some deformation of spring. So if you have a pair of microelectrode, and then it can cause this kind of deformation of spring, right? So that similar to our previous slide, so that in this case, that means we have omega, right? Input the angular rotation, rotate your smartphone, and then you cause some deformation about spring, right? And then you try to look at C, trans capacitance, right? And then in this case, you can measure output equal voltage. So this is a very basic introduction about how this kind of micro mass spring system, right? Of course, the key here is to have harmonic vibration of this micro mass spring system, right? In this case, I can try to detect angular velocity omega, right? So this is something I just tell you without very complicated modern simulation, so that this is a very basic way to give you this kind of idea of how this kind of micro gyroscope work. Yeah. Anyway, so that I do believe all of you have this kind of accelerometer and gyroscope in your smartphone, so that this is something is quite common. And of course, here if we open up your iPhone, and then there's a one tiny chip, right? It's not the IC chip. It's this kind of micro accelerometer, micro motion sensor chip. So that and then the sensing, I show you iPhone. Most of, I would say almost 99.9% of our new smartphone has this magnetic sensor, right? So that actually the company Asahi Kasei now actually is almost the #1 in the world to make this kind of low cost magnetic sensor for digital compass. Again, I think you can also turn on that smartphone app, right, to look at the compass, so that they really try to have very tiny this kind of Hall effect sensor. So this is a one type of magnetic sensor. Hall effect sensor basically there's some interesting semiconductor based magnetic sensor. So that once you have magnetic field, and they can change this kind of a property, right? Electrical property, so that in this case, they can do this measurement. And basically, if there's some magnetic field, maybe called B, magnetic field, and then so that then you can change what? This kind of semiconductor property of Hall effect sensor. So most likely, it can reduce some of the maybe change of resistance, right? Semiconductor, this material property change, and then you can look at the output voltage. So this is very basic way to discuss how this we can make this work. It's basically, it's a magnetic field. Magnetic field for our smartphone. Most likely, what do one measure? Huh? Magnetic field of the Earth, right? So that's the compass. This is a compass. Okay. Of course, the one in your smartphone is not the sensitivity is not very high. That's why they still need to do what? Calibration. I don't know if you have ever played with this kind of a smartphone's compass app. Sometimes they ask you to do some calibration. Did you have some experience to use this kind of this compass in your smartphone? Huh? Do you have some experience? Any of you play with this kind of compass? At least I would say most likely 99% of your smartphone have this kind of thing. Okay. Okay, very good. What one student mentioned, they have to do this kind of move around your smartphone and do some kind of calibration. Like figure A motion calibrate this kind of magnetic sensor. Okay, because they're always somewhat. Why? Because there's a lot of noise inside. For this kind of low cost magnetic sensor, there's no noise too high, so that's why sometimes you calibrate and make sure you have a good this kind of performance. And so that this is something yeah. Actually, I do have one PhD work on this kind of a family of this kind of a new type of magnetic sensor. So magnetic sensor is a actually has been a lot more application, right? Not only for this smartphone, but also what? At this moment, one of my PhD students try to look at local CMOS magnetic sensor for what? For energy monitoring. So how can we monitor all this kind of electricity power consumption in the building, right? So that, and the key question is, can we make this quantity cell power? That quick thing, right? Cell power. Can we have this kind of cell power? This kind of sensor, magnetic sensor, to measure this kind of energy, right? Energy in the building, right? For monitoring this kind of energy in building, in smart building. So that again, I do have one PhD student work on this kind of cell power, micro magnetic sensor, right? And also think about how can we maybe do this sensor fusion, right? With this kind of micro such core magnetic sensor, integrate with this Hall effect sensor using, for example, semiconductor foundry like TSMC, Global Foundry. Then we can make some dual mode magnetic sensor, which has much better performance. Okay, and so that's something I tell you is quite useful or not. Why not? As I mentioned, this kind of sensor has a lot more application. Why? First, of course, this kind of magnetic sensor have been widely used in smartphone, and in the near future, this can be used for smart building. Again, I do have an ongoing project about this kind of micro magnetic sensor for energy monitoring. Right, so this is something that give you some idea. Of course, if interesting, of course, I can give you some paper. Right, my PhD student have published, and of course, another thing we'll mention as even in our video, right? Video on things so that one student asks, Google Map have some kind of calibration? Typically, this is a very good question, right? Typically, in old days, before all this kind of sensor, local micro sensor, become so widely used in every smartphone. GPS, right? Google Map use GPS to get this kind of data from satellite, but sometimes the signal too weak, or it may be in the in Hong Kong downtown area with very tall building, it block this kind of signal from satellite, and then that's why I would say most of this kind of smartphone apps, Google Map or some maybe Baidu Map or something, they will use not only GPS but also use those mass motion sensor, right? For this kind of improve the performance. That means I would say all the Google Map or other similar map, this kind app in your smartphone will use this kind of GPS chip plus this kind of main sensor, motion sensor. All right, like accelerometer, gyroscope, and also digital compact. Why? For this kind of to improve this kind of accuracy, I would say. Okay, this kind of navigation. So this become, I would say, become very common now, especially many time the satellite signal, right? It's maybe two-way, so that you may need using your smartphone mains motion sensor, right? Mains accelerometer, gyroscope, even the compass to do the kind of sensor fusion. I would say they call it sensor fusion. Okay, sensor fusion. This has become very common. Yeah. One student also asked how to monitor energy, different uses of the different app. To monitor energy, so that in our building, what kind of energy we're talking about in the building? As I mentioned, typically energy in the building consists most likely have I would say two major this kind of energy consumption, or three probably. One is energy used in the electricity, right? Right, this kind of energy. Another one, electricity is another thing. Why? So we need to need power consumption in the electricity. In this case, if we have this kind of magnetic sensor, so that if you still remember the basic this kind of universal physics, so that once you have a cable, why there's a current, electric current passing, and then based on basic physics, you're going to have a magnetic field, right? So that if you are able, all this kind of electric, the cable to power computer, power all electrical appliances at home in the building, then if you are able to measure magnetic field, so that you can actually measure this measure current, right? And then of course the voltage, right? The voltage for typical AC voltage is fixed, right? So that in all all this kind of power supply from COP, so that in this case, once you measure current and V voltage is fixed, in this case, you can easily calculate this kind of effective V and I, so you can find the power consumption of the thing for the building. And this is the first thing. Second thing for energy is energy using an HVAC, heating, ventilation, and air conditioning. Why? And number three, most likely maybe energy for what? Like town gas, natural gas. Why do you say? At least in Hong Kong, we have this kind of town gas provide this kind of thing for home appliance, especially for heating, water heater for bathroom, and also the heating maybe in the kitchen, right? So that's something very common. Okay. So that I don't know if I answered the question. For one student, they asked about this, how to monitor this kind of energy in this kind of a building. So once you have a sensor, right, micro sensor to measure this kind of energy, the next thing, of course, we need to have what? Additional app, software. For example, a smartphone have a program, an app to get those data, sensor data, and then to do processing. Okay, I can show you. You can see. So that something is another quite important thing. Right? Micro sensor need to have a certain kind of amplifier circuit, and then ADC into digital data, and then we can using computer or smartphone app the program to process this kind of sensor data to look at the energy consumption, look at the this kind of information about the kind of direction for magnetic sensor. Okay. Of course, this kind of mass motion sensor also have what's a calibration. This I'm pretty sure there's some video game. Why? The video game app in your smartphone, and then they may use the kind of motion sensor or some sensor or GPS for AR or VR AR, this kind of game. So that's another, I would say, another quite important and interesting application, right? So that I do believe some of you play some video game your smartphone, and then so that some of these main motions will be useful, right, for certain kind of gaming. Yeah. I remember also another quite interesting popular game, right? Pokemon. I don't know if you play some Pokemon, this kind of AR, this kind of game, right? So that this is the AR, right? Means how you use a webcam or your camera of your smartphone, and then so that you can play some of this kind of AR or VR game. I think this is another thing. So that yeah, and of course, let me quickly go through as I mentioned in this kind of introduction of this kind of man's video. So that TI is only one company who make this kind of digital micromirror array, or DLP, right? They spent almost 20 years to turn this kind of micromirror array into real product. And of course, as I mentioned, it's only one company in the world that can really make this kind of TI's DMD chip. And so that, of course, as I mentioned, like this has a lot more application, including the computer projector, right? The series of a company in Shenzhen or main China that use this kind of TIDMD for computer projector or Pico projector, right? But of course, the micro mirror, as mentioned, can be used for what? For example, like Intel. Intel have this kind of LiDAR, right? So that the Intel use this kind of a micro mirror made by ST Microelectronics for this kind of MR application, HoloLens 2. So that doing that, so that I don't know if you have ever played with this kind of VR AR, this kind of headset. So at least let me show you. Michael, did you have you ever seen this kind of HoloLens too? Huh? They do use this kind of ST Microelectronics micro mirror for this kind of thing. So that I just tell you, this is something quite important for you to understand. A lot of this kind of MEMS sensor and actuator, they do use this kind of MEMS actuator, right? Micro mirror. So that this is something is I would say become more and more common now. So that so this not only micro sensor but also this kind of actuator micro mirror as used in this kind of VR, AR, or MR application. I may also try to just give you this kind of additional reference for you to look at this one, so that and maybe quickly show you this thing, so that again, so not only can use for micro mirror, not only can use for computer projector, but also using for this kind of VR, AR, MR application. So that this is a AR, VR, AR is another important computing platform, and will be huge amount of this opportunity and make a big money. So that at least I just tell you this thing, so that micro mirror, right, have been important for this kind of laser beam scanning for AR, this kind of display, and then so that HoloLens too, right? Nose, you see, these are real, right? How to use micro mirror, right? And with this kind of laser scanning, so you can make this kind of wearable, this kind of smart glass, and HoloLens too is also using this kind of micro mirror, right? And thing, but of course, to look at design, you can micro mirror here, the design thing, so that it's non-trivial. But again, now those big company spend the big money to make this kind of low cost micro mirror with integrate this kind of circuit, right, for control this micro mirror for this kind of laser scanning. So that doing that. So this is something I tell you is become very, very important, right? So that micro mirror is not only used computer projector, but of course I also mentioned in the last week's thing, so that this DMD have been also make a new family of product. For example, like Berkeley Light. I mentioned Berkeley Light, right? I went to IPO more than 1 year ago. They use DMD to do this kind of manipulate meaning of cell, right? And then so that is another quite important application doing that. So that there's a long list of this kind of thing. So micro mirror seem to be of course the main LiDAR for self-driving car is also big business. So that doing that. So that I tell you, there's a series of this kind of application of this micro, not only micro sensor, also micro mirror, so that you may want to think about this kind of opportunity for you. I think so that is something is quite important for all of you to look at this kind of application. Even you don't know this how to make this one, but how this kind of thing will big impact in this kind of a series of industry. Let me quickly also show you about this particular one. So the Berkeley Light as use digital micro mirror array for their product. It's I would say it's another went to IPO more than 1 year ago and then become unicorn. Right? The market value. Listen, if you are able to use this kind of micro sensor to our micro actuator, micro mirror for new application, you can become super rich. I just tell you this is quite basically they use this kind of micro mirror array to optically manipulate this kind of the cell, right? And this kind of optofluidic tray, and then so that this have been used a series of biotech pharmaceutical company, so that again, so this micro mirror has been useful, right? For this thing, and optically I can manipulate millions of cells for biotech, for pharmaceutical company. So that this is quite important for doing that for cell therapy. You know that we have this kind of a cancer immunotherapy, how to get your own like white blood cell, right? T cell, and then program, and then try to do the cancer immunotherapy. So that definitely this kind of new micro mirror array has enabled this kind of new family of product, so that this product is give this kind of breakthrough in biotech and medical field, right? So that they can really create a series of this kind of application, doing that, for biotech company, for pharmaceutical company. That's why this company is market value. Do you know how big is market value of this company? How big is the I didn't tell about all the technology, but it is how big is this market? Do you have some idea? Any idea about it? This how big is this company, Berkeley Light, after went to public in New York stock market? How big is the market? The market capital. I want to say, what is the market capital of this Berkeley Light? Berkeley Light Incorporation. One student said 5 million. You are joking, You are joking, What? Paul Yan say it's 5 million. Market. This is a public company. This is U.S. public company. Market capital. One student said 20 billion. I think it is. You can Google, right? It is a public company. I think it is. 1 year ago, it's about 5 billion US$ capital. If you are able to use all this kind of micro sensor or micro actuator, micro mirror for new application and have impact, you can make a big money. This is a Berkeley Light. It's not 5 million. It's a really big company, has a lot this kind of application for biotech medical field, so that you can quickly look at market capital of this Berkeley Light, so that it's something. I'm not joking. This is all this can be easily found on this kind of public website. Let me quickly show you the number here. So this is Berkeley Light. Basically, is a public company, right? So that you can easily look at the market capital. What? Oh, it make it smaller now. But still 457 or 158 million. I remember 1 year ago, is market capital is about 5 billion. Well, all the market, stock market, like go up and down, so that at least after this kind of IPO, I know there's a one period of time this company is like it's like market value is about 5 billion, so that it's go up and down. But definitely, I do believe that this has a lot more applications, so that definitely all the if your product has a really have a breakthrough and for a lot of application, definitely you will your company will continue to grow, right? So I do believe this kind of micro mirror for biotech will be quite important, so that I would say this will continue to expand their market and business. Of course, a main gyroscope can also use the kind of Segway scooter, and then I think we also see Pico projector computer is one of a big market in Shenzhen next to Hong Kong, so that you can find a series of the computer projector from Alibaba Taobao.com, and for also using have the TV, and then anyway, so there's a series of things. I think we almost run out of time, so that I don't know. Do you have any question? I think we need to quickly finish this up. Do you have any question about this thing? Of course, we also maybe just using 1 minute, right? So again, this kind of micro actuator, bubble jet actually is also quite important. The idea is micro heater, you heat up, suddenly in ratio between heat up this kind of liquid in, and then vaporize, become the bubble, vapor bubble, and then suddenly this bubble has a lot of pressure to push in out of nozzle because of mechanics, hydrodynamic instability during droplet. So that this is quite important thing. I just show you this is in very short period of time, about 10 milliseconds. So they can heat up. The heating rate is very high, and then during this kind of bubble, right? So that of course this has been make a very good product for high speed printing, right? So that at this moment you can easily buy this kind of inkjet with 6,000 this kind of nozzle, micro nozzle for inkjet unit, right? For this kind of low cost, high speed inkjet printing. Okay, so that of course, finally, I also mentioned about this thing, right? So microfluidics, right? Or inkjet is one of a microfluidic device, right? Has turn this liquid into vapor bubble to the printing. Another important microfluidic is for, or nanofluidic is for this DNA sequencing. So that in the past 20 years, so that this kind of cost of the DNA sequencing reduced at least almost 6 order of magnitude. So that it's more slow. Okay, in some company, and then at this moment, so that once you have a order of magnitude reduction of the cost, you have a big business potential. So that in this case, you're going to have a huge potential in biomedical field. So that now Oxford Nanopore can really make a portable DNA sequencing thing, right? Actually, I also have a project about how to use TSMC to make a CMOS ISFAB for this kind of DNA sequencing or detection or biosensing, detect this kind of DNA, RNA. So that is something quite important in this biotech. Okay, and then of course, let me quickly go you. So I was mentioning in the video, basically for microfabrication, basically you have this kind of simple micro machine, bulk micro machining, right? So basically you do some etching and deposition of thin material, and then so you can freestanding micro beam. Bulk micro machine basically is do an isotropic etching on the bulk silicon, right? So that most I use wet chemical. This is dry etching, right? And then of course, finally, I just quickly show you. I think sorry, we run out of time, so that if you have any question, if not, probably we will maybe stop here. So that maybe if question, please don't hesitate to ask question on our campus website, especially if you think your exam online exam is not good. Please ask